Okay, this is a video for Unit 3, Activity 5, which is generating table of values when we're given an equation. So these are both equations of lines, and if we wanted to graph these lines, one thing that we could do is generate a table of values first. So a table of values, the first column is going to be my independent variable. My second column is going to be my dependent variable. So I'm going to first do this by hand and then show you how you can make this process more efficient with a spreadsheet. So the first thing to think about is that we can pick any values we want for the independent variable. So the way an equation of a line works is it's kind of like a machine where I input the independent variable and it will spit out the dependent variable associated with that value. So it's usually easier, especially if we're going to graph this line, to pick numbers that are around the origin and using an increment of 1. So each time I'm increasing my x value by 1. So I've got 2 points to the left of the origin. I've got my x value of 0 and then 2 points to the right of the y-axis as well. If you were working with a real-life situation, you might choose to use positive numbers or different increments. And what I'm going to do is I'm going to substitute these values for x into the equation to figure out the associated value of y. So again, you can think of that kind of machine analogy. I'm inputting an x, and my equation is like a machine that's going to spit out an output or a dependent variable of y. So for my first value, I'm going to plug in -2 for x, because that's in my first row of the table. So -3 times -2 is +6, plus 1 is 7, so I must have a y value of 7. And I can continue, and I can do that for each of my 5 independent variable values. -3 times -1 is +3, plus 1 is 4. And as I'm doing this, see if you notice a pattern. Anything times 0 is 0, plus 1 is 1. Do you notice a pattern on the dependent variable, the y values, and something that we're going to talk about in future lessons in this unit? -3 times +1 is -3, plus 1 is -2. I guess just a theme of this course is be really careful with your negatives as you're working on these. And then I finally got -3 times +2, that's -6, plus 1 equals -5. So each row of the table is giving me a point that I graph on a Cartesian plane and connect them with a straight line. If you weren't able to connect them with a straight line, then you must have made an error somewhere in your calculation. So for example, this first row, that would be the point, let's put it here, -2, 7. And then this last one is the point +2, -5. You actually only need 2 points to graph a straight line. You can just put your ruler between any 2 points. But it's helpful to have more points to check your work, to notice any patterns, etc. Sometimes we don't have the equations in such a nice y equals mx plus b form. So we call this form of the equation of a line y equals mx plus b. If I don't have that form, I think it's helpful at the start to rearrange it. So I'm going to rearrange so that I can get this equation to be in the y equals form. So I'm going to move the 6x onto the other side where it becomes a -6x. And again, I want the part with the x in front of just the constant. And now to get y by itself, I need to divide everything by -2. So I'm going to divide all of these by -2. So that's going to get me just y by itself. -6 divided by -2 will be +3x. And then 10 divided by -2 is -5. So now I have my equation in the form that we prefer, y equals mx plus b. And now again, I can generate any values I want for the independent variable. I recommend picking increments of 1 close to the origin. It's going to make it easier to graph. And again, to figure out what values I need to plug in, I need to do just a little bit of math. So I'm substituting in my independent variable to find my dependent variable. 3 times -2 is -6. Take away 5 is -11. Then I have -8. And again, see if you can notice a pattern. Do you see this number showing up anywhere in the table? Do you see this number showing up in the table or in a pattern that you notice? We'll talk about this in more detail in future lessons, but it's always a good idea to look out for patterns that can make our work more efficient. 3 times 2 is 6, minus 5 is 1. So again, I've generated a series of 5 points, and I could graph those and connect those with a line as well. So that's how I can generate a table of values from an equation when working by hand. The only other thing I want to show you in this video is that we can do the same thing using a spreadsheet software like Google Sheets. So let's say I wanted to graph y equals negative 4x minus 3. Again, I'm going to generate my table of values. I have an x and a y. Why don't I again fill in negative 2, negative 1, 0, 1, and 2. So they're going to be kind of our 5 most common values of the independent variable to use. And I want to figure out what my y values are. So if I want to generate an equation on a spreadsheet, I need to start with an equal sign. So what I'm saying is that this cell is going to be equal to, and then in my formula bar, after the equal sign, I can type in, I want it to be negative 4 multiplied by the x value, right? Because it's negative 4x. So I'm going to do negative 4 times, and then I click on the cell so it's going to multiply it by whatever is in cell A4. Then I also want to subtract 3, right? That was my second step. So the spreadsheet is going to calculate the value for me. So what's really nice here is that the spreadsheet's doing the math for us. You're thinking, well, why? I could have done that by hand just as quick. You know that negative 4 times negative 2 is 8, minus 3 is 5. Well, what's nice about a spreadsheet is I can just click on that bottom right corner and drag down. And it's going to copy the formula. So I've actually calculated now the entire table of values just in one step. And if I wanted to, I could make this even further. So I could keep going by increments of 1. And I could go as long as I want. So now I've got all my different values of the independent variable. And just, again, with one drag, I can generate this table of values. And you notice if I click on any cell in the formula bar, it's showing me the formula. And it's still always negative 4 times x minus 3. So the spreadsheet can help you do this a little bit quicker or more efficiently. But learning it by pencil and paper is a really important tool as well in kind of developing our knowledge of linear relations. So that's all for now. That's going to let you do your homework for activity 5. Save your work because you're going to hand it in after adding a bit more to it in activity 6. Okay, that's all for now. Bye.